Alright, welcome back, and today we're going to be covering the 2018 AB FRQs. As always, within the description there's going to be timestamps, a link to the PDF of the FRQs, their official solutions, and a Calc 1 textbook that's free and online. Feel free to use those resources, and yeah, let's get straight to it. So this first one is just about people entering a line for an escalator. And we're told that this function models the rate of people going in. We're also told that there's always 0.7 people leaving per second, and that at t equals 0, there's 20 people in line. Alright? The first part is fairly straightforward. It's just asking us how many people enter the line between time equals 0 and 300 seconds. Okay? Well, this is a rate of people that enter. We want the number of people that enter. To go from a rate to a number, we integrate. Right? So we're going to have the integral from 0 to 300 r of t dt. And you are going to have to plug this into your calculator, but in the paper you can just write this down instead of all that. And then once you plug that in, you should get 270 people. Alright, for part B, we're just asked to find the amount of people in line at time equals 300. And we're going to build off of our answer for part A for this. So, as you remember, part A was integral from 0 to 300 r of t dt, which is going to equal, I'm going to use big R to denote the integral of this function, big R of 300 minus big R of 0, right? And so, to get big R of 300 is just the integral for our answer from part A, plus the amount of people in line at time equals 0, which is 20. Okay, but now we subtract the rate at which people left, which is 0.7 times 300, because we're asked for at time t equals 300. Alright, so you should get this expression, and then you plug this into a calculator, you'll get 80 people. So at t equals 300, there's 80 people in line. Now for part C, you're asked that for time greater than 300, when is the first time that there's no people in line? And now one thing to keep in mind, after time equals 300, no one is entering the line, which means we're only losing people at a rate of 0.7 people a second. Okay, well, we know it's going to be sometime greater than 300, right? Because we already are at time equals 300. We said that at that time there's some people in line, 80 people, right? Well, 0.7 t, which is the amount of people we lose per second, at some point is going to equal the amount of people we have in line, right? At that point, it'll be the value of 80 divided by 0.7. So if you go an additional 80 over 0.7 seconds, then you'll have lost those 80 people in line, right? So the first 300 seconds plus the amount of time it takes to lose the last 80 people in line is going to be our answer, which comes out to be 414.285 seconds. Alright, now for part D, we're asked to find the time where the number of people in line is at a minimum. Okay? Well, we first have to figure out some way to figure out the number of people in line, not just the rate going in or out. Okay, well, we know if we integrate the rate from 0 to t, right, we're going to get the amount of people that have entered, right? But then we also need to subtract 0.7 per second, because that's how many you're leaving. And then this integral, we're going to integrate this. We'll get r of t minus r of 0, okay. But hold on, we can't have two unknowns, right? But then you realize r of 0, that's just the amount of people in line initially, so it's actually just plus 20. Okay? So now, if we take the derivative of this is going to tell us the where our minimum happens, because to find the minimum, we've got to do the derivatives, we have to do the first derivative. So let's differentiate this. We get r of t minus 0.7, and this needs to equal 0. Now you are going to plug this into your calculator because you are not going to be able to do this by hand, but you should get two values denoted by T1 and T2. T1 is 33.013 and T2 is 166.574. Okay? Now we have these two values. We also need to consider two other values, which are 0 and 300. Why 0 and 300? They are endpoints. We still need to check the endpoints. Right? So now what we do is we plug in these respective t values for this. Alright, well, if we plug in 20 plus the integral from 0 to 0 r of x dx minus 0.7 times 0, that's just going to be 20. Okay. If we do the same thing but now with 300, keep in mind I'm doing these two first because these are either easy to evaluate or we've already done them. Minus 0.7 times 300. Well, this looks similar to what we did in part A. Part A was the same integral. Okay, so that's 270, 290, and then minus that. That's 80 people. Okay, now let's do T1, which is 33 point some change. So 20 plus the integral from 0 to, I'm going to write T1 here, rx dx, r of x dx, minus 0.7 times T1. Please note T1 is not a variable, again it's this value. Now this integral, don't bother doing it by hand. You have a calculator, use your wonderful calculator. You should get a value of about 3.803. Okay, let's move on to the last value. Same thing, same integral, except now we're just changing the upper bound like always. And again, do not try to evaluate this by hand. You have a calculator. Please use your calculator, okay? This integral comes out to be 158.070, okay? Now we're told that we need to find the minimum. All right, well obviously the smallest number here is 3.8 and 3.803. But you can't really have 0.803 of a person, so we're just going to round up to 4 people. Right? So at T1 there's 4 people in line. And that concludes this first FRQ. Alright, now for the second FRQ, we're told that some particle, I'm going to call it particle 1 because there is a second particle that comes in later. So subscript 1 refers to the first particle. Has a velocity given by this function between time equals 0 to 3.5. We're also told that its position at t equals 0 is -5. And this first question, very straightforward, just find the acceleration of the particle at time equals 3. Okay, well how do we relate velocity to acceleration? The derivative of velocity equals the acceleration, right? Which means the derivative at t equals 3 equals the acceleration at t equals 3, and this is where you put it into your calculator to get -2.118. And that's it for part 1. Just plug it into the calculator. Now for this second part, we're just asked to find the position of the particle at t equals 3. Okay, how do we go from from velocity to position? We integrate, right? And if we want to go from position to velocity, we would differentiate, but we only have a function of velocity, right? So we're going to integrate the velocity from 0 to 3 to get the position at 3 minus the position at 0. Okay. Let's move over the position at 0. So you get the integral from 0 to 3 of the velocity function. This marker's dying out. Give me 1 second to swap markers real quick. Plus, this is barely any better, the position at t equals 0 is just the position at t equals 3. Okay, this you're going to have to plug into your calculator. This you're given, which is -5. So if you do all this, you should get -1.760 as your position at t equals 3. And yeah, fairly good FRQ so far. Now for part C, we're asked to evaluate these two integrals and then just interpret what they mean. Okay, well let's just do the easy part first and just plug them into the calculator. This first one you should get 2.843. The second one, which is just the absolute value of the velocity function, you should get 3.757. Or sorry, 3.737. Okay? Now that's the easy part because that's just putting it into the calculator. But what do they mean? Well, we said that the integral of velocity is the position. We're integrating velocity in both cases, except this one's the absolute value of velocity. Okay. Well then, what's the difference? This, the absolute value one, is the distance. That means we don't care where we're going, we just care about how far we get. And you can't have a negative distance. Okay? So, this integral means that the distance traveled from 0 to 3.5 seconds is 3.737 meters. While this one means that the displacement from 0 to 3.5 is 2.843 meters. So again, the integral without the absolute value tells us about the displacement, which is 2.843 meters, while the integral with the absolute value tells us about the distance. The way to remember this is that absolute value is always positive and you cannot have a negative distance. If you are oriented some way, that way could be negative, that way could be positive, but it could be still some positive distance. And that is the part C of this FRQ. Alright, now for this last part of the second FRQ, we're told that the second particle has a position modeled by this function, t squared minus t, from 0 to 3.5 seconds. And we're just asked to find at what point are the velocities of both particles the same. Okay, what does that mean? Well, we already have the velocity of the first one. We don't have to worry about finding that. To go from the position to the velocity, we have to differentiate, right? In this case, it's fairly simple to differentiate. You just get 2t minus 1, okay? Now you set 2t minus 1 equal to this function. And now here's where you're going to graph this into your calculator and figure out where they equal each other. And you should get t equals 1.570. So at t equals 1.570 seconds, the particles have the same velocity. Alright, this third FRQ gives us some function and its graph, g. We're also told that this graph also represents f prime. And it's pretty much linear parts and then a quadratic. I'll probably throw up the PDF here just so you can see it nicely. Alright, so part A is just asking us to find f of -5 given that f of 1 is 3. Okay, how do we do that? Well, we have the graph of f prime. To go from f prime to f, we integrate, right? So the integral from -5, which is what we want, to 1, what we have, of f prime of x dx, is then going to give us f of 1 minus f of -5. Okay, let's just isolate f of -5 to have a cleaner equation. The integral expression stays. And then we subtract f of 1, which is saying subtract 3, is going to equal negative f of -5. Multiply both sides by -1, you get the negative integral from -5 to 1 f prime of x dx plus 3 equals f of -5. Okay, now let's find some area under a curve. As you can tell, I've dotted what we're going to break it up into, because we're going from -5 to 1, right? So there's two triangles and a square. Okay, the square is the easiest thing to find the area of, because it's just fairly straightforward. All right, it's base of 3, height of 3, area is base times height, so it's 9. But because it's underneath the x-axis, it's -9. Okay, not too bad, not too bad. Now here we have a triangle of height 3, base 1, and again, underneath the x-axis. Area of a triangle is half the base times the height. So you get half times 3 times 1 times -1. You get -3 halves. This triangle here has a base of 1, height of 2. It's above the x-axis, so it's positive. So it's going to be 1. I'm going to write this as 2 halves and convert this into 2 halves as well, just so we can deal with the fractions easier. Now let's add them all up. You get negative 21 over 2 plus 2 over 2, you get negative 19 over 2. Okay, now we're going to use this into this expression here. It's negative, so we're going to make it a positive, right? Because a negative times a negative, positive. So you get 19 over 2 plus 3 equals f of negative 5, which is 25 over 2. And that concludes part A. Alright, now for the second part, we're just asked to evaluate this integral. Please note that this is the equation that they gave us for the parabola. We are going to have to use it in this part. I just wrote it down. Okay, well, that's telling us to integrate from here to here. Okay, well, we can integrate from 1 to 3 just by calculating a shape's area. But then 3 to 6, we do have to actually integrate. So we're going to break this up into the integral from 1 to 3, g of x dx, plus the integral from 3 to 6, g of x dx. Okay? And now this is a square, height 2, base 2. So I'm going to use green to denote the area. So then, dot this real quick. Height 2, base 2, that's going to be 4. Wonderful. Okay. Now to get the area from 3 to 6 here, we are going to have to algebraically integrate. Okay. I'm just going to copy down that. We got 4 here. So let's do it. The integral from 3 to 6 of 2 times x minus 4 quantity squared dx. Well, the first thing you can do is take the 2 out. That just makes it look a lot cleaner. Now this is just some fairly straightforward u sub. We're going to let u equal x minus 4, du will equal dx. So then you get the integral, 2 times the integral of, let's see, let's change bounds too, okay? When x equals 3, u equals negative 1. When x equals 6, u equals 2 of u squared du. Okay. Now this is just the power rule. This then becomes 2/3 u to the 3 evaluated from negative 1 to 2. Where did this all come from? Add 1 to the power, that's where we get u cubed, divided by the new power over 3 times 2, and then these are just our bounds. Okay, so we get 2/3 of 2 cubed minus 2/3 of negative 1 cubed. 2 cubed, that's 8, times 2 is 16, so you get 16 over 3 minus negative 1 cubed, that's going to be negative 1, times 2/3 is going to be 2/3. Sorry, negative 2/3. So minus negative 2/3 is the same thing as adding 2/3, so you get 18 over 3, which equals 6. So then you get plus 6 here. So the integral from 1 to 6 of g of x is just 10. Alright, now for part C of this FRQ, we're just asked to find where f is both increasing and concave up on the interval from negative 5 to 6. Okay, well this graph gives us f prime of x. And if f prime of x is positive, then f is increasing. So that tells us right away that from negative 5 to 0 does not work. Okay, but then where is f concave up? Well, how do we get concavity? That comes from the second derivative. So we're looking for the second derivative and the first derivative are both positive. Well, from 0 to 6, the first derivative is positive or 0. That's a good place to start. Now where is the second derivative on that interval also positive? Well, this line here has a positive slope, and so does this line here. Okay, so that means that from x is greater than or equal to 0, sorry, just greater than, and greater than, or less than 1, and x is greater than 4 but less than 6, f of x is concave up and increasing, since f prime of x is greater than 0 and f double prime of x is also greater than 0. So that is it for part C. Alright, and now for this last part, we're just asked to find where where f has a point of inflection. Well, point of inflection, where does that come from? The second derivative. And what do we need from the second derivative? We need to go from a sign to 0 to the opposite sign. Okay, well this is f prime of x, let's just check the slope. Here we have 0 slope, doesn't work. Positive, 0 for a bit, positive. Also doesn't work because it doesn't change signs. Positive, 0 for a bit, negative. It's the 0 for a bit, that doesn't work out. So then we get negative, 0 for an instance, and then positive. That's what we need, because that means that this second derivative goes from negative to 0 to positive. So at x equals 4, since f double prime of x goes from negative to 0 to positive, meaning f of x has a point of inflection at x equals 4. And that is it for this FRQ. Alright, now for this fourth FRQ, we're given a table that tells us the amount of time in years relative to the height a tree grows in meters. Sorry, the height of a tree in meters. Alright, and for part A, we're just asked to estimate h prime of 6 and then interpret what it means. Okay, well, h prime of 6, we're approximating just 2-point slope, right? Our closest numbers are 5 and 7, so we're going to have h of 7 minus h of 5 over 7 minus 5 is 2. 11 minus 6 is 5, so 5 over 2 is 5 over 2. And this is meters per year. So it's approximately growing in 6 years at approximately a rate of 5½ meters per year. Alright, now for part B, we're just asked to explain why at some point h prime of t is going to equal 2. No, you can't just point at h of t equals 2, that doesn't tell you anything. Okay? So, let's see, we're told that h is twice differentiable, so it's differentiable. And if it's differentiable, it's continuous, which means we can use the mean value theorem. So, if you do h of 5 minus h of 3 over 5 minus 3, you get h of 5, 6, h of 3, 2, 5 minus 3 is 2, so you get 4 over 2, which is going to equal 2. Okay? So, by the mean value theorem, some point exists such that h prime of t equals 2, because the 2-point slope at some point is 2. Alright, now for part C, we're asked to use a trapezoidal Riemann sum with the subintervals given by the table to approximate the average height of the tree. Okay, well, average height, that's the 1 over b minus a times the integral from a to b. Okay, and we're using the whole table, so a is 2, b is 10 in this case. So we're going to have to end up multiplying by 10 minus 2, which is 8. 1 over 8, I mean. Okay, trapezoidal Riemann sum, what's that? That's the difference times the average of the two values. Okay, let's just show what that means. The difference between 2 and 3 is going to be 1, so it's going to be 1 times 1½ plus 2 over 3. Sorry, over 2. 1½ plus 2 over 2, not over 3. Sorry. Plus, difference between 3 and 5 is 2, times, added them up, 2 plus 6 over 2, plus, difference between 5 and 7 is 2, times 6 plus 11, sorry for blanking there, over 2, plus, difference between 7 and 10 is 3, times 11 plus 15 over 2. Now, I am going to leave you with this. The numbers aren't so bad, but your final result should be an eighth times 65.75. Yes, you can simplify this further, but why would you? This will give you the same credit. Okay, for the last part of this FRQ, we're told that g of x models the height of the tree, and we're asked to find the rate of change of the height with respect to time when the tree is 50 meters tall. Okay, so we are going to have to differentiate this. Let's just do that real quick. We get low d high, 100 plus x, quantity times 100, minus high d low, 100x times 1, over low squared, but we want this with respect to time, so times dx dt. Okay, simplify this a bit. We get 100 plus 100x minus 100x, so it's just 100. And dx dt, as we were told in the problem, equals 0.03. Okay, but what x value are we plugging into? Well, we want this when that tree is 50 meters tall, which means g of x has to equal 50. If you just try and plug it in, you're going to realize you already have 100 here, just divide by 2. To get that to happen, x has to equal 1. So g of 1 equals 50, which means we can now plug in this and this to get 100 over 4 times 0.03. And you can leave it as that, or you can simplify it to 3/4. Is your choice. Alright, now for FRQ 5, we're just told that f of x is e to the x times cosine x. That's all. For part A, we're asked to find the average rate of change on the intervals 0 to pi. Okay, average rate of change, derivative. Now if you're like over rushing and overthinking, you might be thinking, well, I know the average integral is a to b 1 over b minus a f of x dx, and you might try to do this, but that's not going to work out because this is e to the x times cosine x. You can integrate this by hand, but it's not part of AB, so please just don't even think of that, right? What we're instead going to do is a much simpler thing of the 2-point slope. So we're going to have f of pi minus f of 0 over pi. Okay, let's just start plugging in then. Well, e to the pi, that's just some number. Nothing we can do about that, right? Cosine of pi, that's going to be on the unit circle all the way over here. That's going to be -1. So that's going to be negative e to the pi, then minus f of 0. Okay, e to the 0, that's just 1. Cosine of 0 is over here, that's just positive 1. So minus 1. So that's your answer for part A. Alright, and now for part B, we're asked to find the slope of the tangent line of f at x equals 3 pi over 2. Okay, slope, tangent line, your very first thought should be, I need to get a derivative. But you do. So this is going to be a product rule. So we're going to have left, derivative of the right, derivative of cosine is negative sine, plus right, derivative of the left. Okay, now we're going to plug in x equals 3 pi over 2. Okay, so we get negative e 3 pi over 2, it's just some value, times sine of 3 pi over 2. Okay, let's look at our unit circle. 3 pi over 2 is down here, so sine is going to be -1, so it's going to become positive, right? Then plus e, again, 3 pi over 2, nothing you can do about it. And then we're going to have cosine of 3 pi over 2, which is again over here in the same spot. But this is 0, so in actuality, you just get e to 3 pi over 2. Alright, and now for part C, we're just asked to find the minimum value of f on the interval from 0 to 2 pi. Okay, so from part B, we've said that f prime of x was negative e to the x sine x plus e to the x cosine x. Okay, now what can we do? Well, we need the first derivative to be 0, so we get 0 has to equal negative e to the x sine x plus e to the x cosine x. Well, let's just factor out an e to the x. So 0 equals e to the x times negative sine x plus cosine x. Okay, now you're wondering, what do we do now? Well, now we have to either make e to the x equal to 0 or negative sine x plus cosine x equal to 0. And now, again, e to the x, quick sketch of the graph, it's going to look something like this. That's never going to be 0, right? Which tells us that negative sine x plus cosine x has to equal 0. Okay, what does that mean? Cosine x has to equal sine x. Where does that happen? Let's pull up our unit circle, right? It looks something like this, right? That's actually a pretty good circle. At pi over 4 and 5 pi over 4. At these two values here, we're going to have sine equaling cosine, right? So x equals pi over 4 comma 5 pi over 4. But we also need to check our endpoints, so throw in 0 and 2 pi. Alright? So, what better way to check all this than a nice, lovely chart? Zero, pi over 4, 5 pi over 4, and 2 pi. Okay, well, let's just start plugging in stuff to f of x. Well, f of 0, let's see, that's going to be e to the 0, 1, cosine of 0, 1. Okay, what about pi over 4? Well, that's going to be e to the pi over 4, cosine pi over 4, which is square root of 2 over 2. Okay, what about 5 pi over 4? That's going to be e 5 pi over 4 times negative square root of 2 over 2. And then 2 pi is going to be e to the 2 pi, just that, because cosine of 2 pi is 1. Okay, and we were asked to find the minimum, and only one of these is negative, so f of x has a minimum of negative square root of 2 over 2 times e to the 5 pi over 4 at x equals 5 pi over 4. Alright, and now for part D, we're told that g is some differentiable function, g of pi over 2 is 0, and that we're given the graph of g prime. I'm going to, editing magic, put it up here. I would not be able to draw it accurately. But I do want to note one key thing from that, is that g prime of pi over 2 equals 2. So g prime of pi over 2 equals 2, and g of pi over 2 equals 0. Those are the two key things that we are told. Okay, now what are we asked to do? We're asked to evaluate the limit as x goes to pi over 2 of f of x over g of x. Okay, well, we just said g of pi over 2 was 0, which means we better hope that this becomes L'Hopital's, right? Okay, what's f of pi over 2? Well, that's going to be e to the pi over 2 cosine pi over 2. Quick little unit circle. Pi over 2 is up here, right? Cosine is going to be 0, which means, yep, we get 0 over 0. So now, we get to use L'Hopital's rule, which makes this the limit, same points that x approaches, of f prime of x over g prime of x. Okay. Well, we were given by the graph that g prime of pi over 2 equals 2. So that's going to be easy. Now, here's our derivative for f. Let's plug in pi over 2. We get negative e to the pi over 2. Sine of pi over 2 is 1, so we're just going to leave that alone. Plus e to the pi over 2 cosine pi over 2. But wait, we said that was 0, so this all cancels out. We get negative e to the pi over 2. And that is your answer for part D. Alright, now for this final FRQ, we're given this following differential equation, and then a slope field. And we are asked to graph two solution curves. One that passes for the point 0, 2, and the other that passes for the point 1, 0. Editing magic, I'm going to put them both up here somewhere. Just make sure you connect the dots essentially. One of them is literally just a straight line, like a flat straight line. You can 100% do that, you got that. Alright? And now let's move on for part B. Let y equals f of x be the particular solution, given that f of 1 equals 0. And then we're asked to approximate f of 0.5. Sorry, 0.7, not 0.5. Okay, well, approximation, right, is going to be y minus y1 equals the slope times x minus x1. Okay, well, we're told f of 1 equals 0, so this becomes y equals the slope times x minus 1. But how can we get the slope? Well, for that, we're going to plug it into here, right? So we're going to plug in 1, 0. This just becomes a third, 0, 4/3. So y is 4/3 of x minus 1. Okay. That gives us our equation. Now let's approximate, which is just going to be f of 0.7 is approximately 4/3 of 0.7 minus 1. And you can leave your answer as that, and it's correct. Alright, and now for part C, we're just asked to find the particular solution given the same initial condition of f of 1 equals 0. Okay, so let's do that. Let's multiply both sides by dx and divide both sides by y minus 2 quantity squared. So we get dy over y minus 2 squared equals x over 3 dx. Okay, well let's integrate the right hand side first, right? This is going to be 1 over 6 x squared plus c, right? Because we have x to the first power, we add a power, is 2, divided by the new power is a half times a third times x squared. Okay, now for this left hand side, it's a bit trickier, but not bad. We're going to let u equal y minus 2, du equals dy. So we then get the integral of du over u squared, which is the same thing as the integral of u to the negative 2 du. Okay, so let's just integrate. We add 1 to the power, so we get u to the negative 1 divided by the new power, so it's just negative. Okay, which means we get negative 1 over y minus 2. Bring this all together. Negative 1 over y minus 2 equals a 6 of x squared plus c. Okay, what do we do now? Well, now we just plug in 1, 0 to get negative 1 over negative 2 equals a 6 plus c. Subtract a 6 from both sides, and we're going to sort this out. We get 1/2 minus 1/6 equals c. Okay, and we can rewrite this as 3/6 minus 1/6 equals c, which is 2/6, which is a third. So c is 1/3. Okay, but now we just gotta make it in terms of y. So you get negative 1 over y minus 2 equals a 6 of x squared plus 1/3. Now you might be thinking, let's multiply everything by y minus 2. You don't want to do that because then it's going to be a lot trickier to deal with. What you want to do is inverse everything. So we're going to raise this to the negative 1 and this to the negative 1. Alright? But one quick side note, this is x squared plus 2 over 6. Alright? So if we invert everything, we get negative y minus 2 equals 6 over x squared plus 2. Alright? Multiply both sides by -1, you get y minus 2 equals -6 over x squared plus 2. Add 2, y equals 2 minus 6 over x squared plus 2, and that is it for this FRQ and this bunch of FRQs. So yeah, as always, if you found this helpful, please consider leaving a like, maybe subscribing. If you think I could improve somewhere, leave a comment, I'll try to read them. But otherwise, thank you for watching and have a good day.